I guess that is my cue. The music is down and the spirit is low. Well, welcome this afternoon. It seems like we are in an energy low due to lunch time and no one had the coffee kick up yet. I hope you have some coffee coming in here. This place is super cool because it's an improv place. So that's what I'm going to do. I'm going to improv my whole presentation, see how it goes. All right? Will that work? And then we do a whodunit mystery just to keep the energy high. Because we are so few in the room, maybe we can accept questions. No, maybe not. He asked me whether I accept questions in the beginning or during or at the end. So we waited for the end to do the presentation. My name is Alberto Martinez. I do work for Qualcomm. I'm responsible for the software strategy in the compute business. What does that mean? I'm not sure. It means I have to look into the future with a crystal ball, check it a little bit, to say where is agentic and orchestration and all these fancy works are going, and look at it to say maybe sometimes. But I learned something in my experience, almost 40 years in the industry, that if you want the future, if you want to predict the future, it's a famous quote, so I don't know who said it. There's many attributions to it, but if you want to predict the future, you have to go and create it, right? If you wait for someone to create it for you, then you're a follower. If you create the future, then you are the innovator, right? The people that follow. So my story today is about uncovering a mystery in the agentic story and the orchestration story, and start peeling that onion to try to understand where does it go, right? What do we need to do? One thing is very clear is while we are relying on AI, specifically in agentic and big models, all sizes, to do work for us. By the way, show of hands, raise your hand if you use AI queries, prompt, or activities more than a few hours a day. Let's say you spend hours during the day. Raise your hand. My friend from Qualcomm should raise your hand, otherwise you are punished. All right. So few of you spend it. How many of you had actually run out of tokens? Yeah, you run out of tokens? I actually. I had a measure of how running out of tokens affects my daily life. Obviously, at the office, we don't see the token running out until the CIO come back and say, okay, guys, you're cut off. What they see in the back end, right, is the dollar counter going up, right? And people asking, okay, when is this going to stop? And this is a trade-off that is happening. We're replacing we're amplifying people. I feel 10x more productive since I use AI in a daily basis, and I use it all the time. Not only for research, but for development and for practice. But at the same time, my dear wife, she's an attorney. She's not a technologist, and she uses AI. And we had a personal account. And in a personal account, I wrote out no tokens in a few hours, right? I sit down and start doing things, and I run out of tokens, and they say, chill out, wait until 8 p.m. this evening in order to continue your work. That's never happened to my wife until last weekend. And I say, okay, that's an inflection point. Now it's hitting the consumer, which means we had to do something about it. It's not only making money in the counter, in the back end for people that provide infrastructure and foundational models, but it's also for everyday life that is becoming. And as our Qualcomm CEO, Christian Amon, said in Computex this week, it's multiplying 10x and 100x because agents are just going to run even a higher rate on the token. So it becomes a tokenization or a token economics that is becoming an issue. My talk is about that. And if you take the red thread to the end, the solution's in our hands. It's in our hands, not only from the point of view of the economics, but from the point of view of power conservation, energy consumption, and latency. With that, I told you what I'm going to tell you. Now I'm going to tell you. And then I'm going to repeat what I told you so you can remember that at the end. So I create a provocative message here. Stop routing your docstrings to a 7 billion parameter model. If you're a developer, you know what a docstring is. Basically, you're informing your code of what is that this code does. And but when you take your code and blindly send it to a very large model, you're spending tokens and something doesn't need to go to a very large model. So that is the conversation we're going to have. So we want to talk about token savings, latency reduction that could come up from that, and it's a potential because our research show it could be a latency reduction depending on the hardware that you have and the optimization of models and so forth, but the potential latency reduction, the capabilities and products that Qualcomm provide, I'm sure there are others that do, I don't know who could be, in terms of compute capabilities and memory, and how we analyze in our research how to develop a solution that addresses that problem that I hope you take into account in your next design and your next capabilities that you provide forward. How I break the time here, I have 38 minutes and 34 seconds to tell you this story and allow for questions. First of all, I will tell you about what is the math and why it's broken. I will introduce the Snapdragon X2 Elite, only one page, because I get paid by Qualcomm, so I do need to say these things, right? Then I will tell you a video of our demonstration of a proof of concept that started with an emulator that I created using AI code. The emulator got popularity inside Qualcomm. Our CEO, Cristiano, wanted to demonstrate it at Computex, and I took the liberty to take the same demonstration and bring it here. I will talk about 3-tier architecture. There can be more tiers. I just say the minimum is 3 tiers. That makes sense to me, or that make different sense. Our research and the reference to our research, and we wrap it up. Is that a good plan? Or should we put some EDM music so you guys can wake up?
Good plan.
Good plan? All right, thank you. Okay, where's the broken math? If you add docstring into your prompt, as your prompt contains processing docstrings, it takes about 180 tokens. That's our research. Changes. If you're using the cloud, you're sending to a model that is over 70 billion parameters. That's the smallest, right? If you're fixing a lint error, you're spending 210 tokens. If you're generating a scrub route, 460 tokens. If you're doing a security audit, it goes off the roof. You start with 3,800 tokens to create it. And if you do a cross-repo factory, which is about the same complexity in our research of security audit, is 3,900 tokens. Okay, your miles will vary based on your classifier and so on and so forth. I'm using this as an example. All the small letters said that. So don't use money in that. But it costs money. All these things cost money. Those tokens cost you money. In the lower side, people are spending $36,000. I have heard anecdotally from vendors and partners that in some cases, they're spending $35,000 per developer per month. I will say that is probably Qualcomm case, our own data. But if you take it in the low side and the average of the curve, looking at the distribution in the lower side, those things $36,000 is 50 developers. So there's a wide range of people spending money on this. What we do know is when you apply agentic and orchestration to these functions, this goes 10x. So now we're going to, at least, and so this means instead of $36,000, we're going to be paying in short order, because this is an exponential growth curve, you will have $350,000 or $3,300,000. Peter Stamberger was talking about he's spending $1 million a month, right? Well, maybe he can do that. I cannot afford it, personally. Genius that he is, I cannot afford that. When you look at the workload distribution of this complexity, you see that about 34% of all this workload, when you take a prompt, on average, you take that, we use Claude Sonnet 4.6, and the data coming from Claude Sonnet 4.6 to create this distribution, you will see that about 1,300 queries are simple in the score of 1 to 4 complexity, and I had reference of how that score is measured. About medium to low, about 1,500 queries of that. Medium to high, another 7%. And by the way, if you send those queries to a Snapdragon X2 Elite with a capacity and compute and memory bandwidth that it has, you can run it locally. Now, the remaining is complex. 20%, sometimes 30%, that you will have to send to a model that the X2 Elite cannot run. You can send it to a more capable on-prem device, or you will send it to the cloud. So it's talking about 3 tiers. That's what we had in mind. You have your personal computer or the computer at your desk. You might have a workstation or an on-prem headless machine, and then you have the cloud. If you think about savings that this provide, you can justify pretty much any hardware in your office. Any hardware sitting in your office. And you can explain that to your CIO. So, and the spec of why we say the Snapdragon X2 Elite, because it's a new generation of product. It has 80 TOPS capacity. It provides 143% greater compute capacity than our previous generation. Provide up to 122 gigabytes of memory, up to 225 gigabytes per second memory bandwidth. That is in the Stream edition, 152 in the Elite edition, and support your favorite data types, generally speaking. Now, there is a differential between data types that I will also talk about because it's important to address. So far with me, right? So, money expenditure, breaking it down, the question is how, right? Let me address for a moment the quantization question. It's tremendously true that developing code in floating point historically have been an easier task, and actually from the point of view of precision, provide better precision. On the other hand, when you use integer formats, especially in the weights, you can have up to 50%, which is not taken into account in my calculations, 50% rank reduction over floating point. So that means a model that takes 50 gigabytes of memory, or 100 gigabytes of memory in floating point, and integer A would take 50 gigabytes, and now it fits in the right format. Then bandwidth savings, because now with the smaller weight size integer, we all know that then you're consuming half the memory bandwidth or a quarter memory bandwidth into using integer 4. And it reduces your power in general for many reasons. But in floating points or integer 16 activations, preserve forward the numerical precision, critical for the instructions, avoid activation collapse, and we support it. The point I'm trying to make that is your power conscious, memory conscious, an integer format or a reduced integer format might take the task. If you look at research in this, the quality gap can be reduced by 5%. If you're in the tolerance of your precision, this is a good thing, is in any complexity score 1 to 7. Now, as you go to a complexity score of greater than 7, then I wouldn't recommend to move your quantization to integers because now your precision is become very, very relevant. Okay, with that plug to the hardware, let's talk about the numbers. What the research showed. If you look at this dual axis, y-axis chart, you will find out on the left-hand side the request per day for this research. Again, we use Sonnet 4.6. And in the y-axis, the average tokens per request. If you divide between, there are about typical tasks. This is a summary of the task. We collapsed the tasks that we did in the research, but there is about 20 to 30 different task types that you can talk about. If you look at the tokens request per complexity, you will see the majority, you see the curve is listed to the left in request per day, and to the right in token complexity, if you see the linear curve. So you can see that on device, you can have up to 3,100 requests. On prem device, there is more capable to do, another 660 requests, and the remaining go to high complex models. That will save you a number between 50 to up to 70% of the computational on your tokens dedicated to computation. The way we divided this, and it was prototype, give us a distribution that you could, using the same $36,000 calculated above, you can save up to $24,000 of that per day by dividing the tasks, or dividing the prompts into tasks that can be executed in independent models. So that would be a 1.6, as of April, 1.6 billion tokens that can be processed locally. I want you to hear that one more time. 1.6 billion could be processed locally. And I'm not telling you a server class on your desk. I'm talking to you about your laptop, right? Or I'm talking to you a more capable workstation. I'm not saying put a rack right in your desk, water-cooled rack on your desk. That's not what I'm talking about. I'm talking about the hardware that you can go and buy today in Best Buy. And you can say 1.6 billion tokens with no quality loss. Zero quality loss. For developers, I mean, especially for the CIO, I don't know how many CIOs are here, maybe not too many, maybe in the cameras on the other side, right? I don't know how many of you, but I'm sure your CIO will love to hear this conversation, and we're making this conversation real moving forward. So what I'm going to show you is the demo, is a video of the demo, because there's no setup here to do an actual demo. But this is the same demo that was shown on Computex by Cristiano Mon, or a version of it. Because, you know, if you're a CEO, your demo can be worked on right until the last minute, right, of the presentation. One can make changes to that presentation. If you are a researcher like me, you ended up, you know, presenting your final deck to the Microsoft Bill gods at least 1 week or 2 weeks ahead of the presentation. And this quiz, I put it a little bit later, but I did the best I could. So here it is. The demo, what it does, we take the send prompt, which said, design a Snapdragon page with a link to a Qualcomm.com with Taiwanese coming lantern floating in the background. Now, this is a super simple task, but it's collapsed, right? It's a prompt that is collapsed. The most complex task in here is creating the lantern floating in the background. It's a little bit of physics model that need to be run, a planning of that in the background, execution of that is some complex code that had to be run. And that is over 70 billion parameters that is required to execute that. So smaller parameters won't do a good work. We try. We have videos of those that do with from 3 billion to 30 billion to 70 billion to 120 billion. We had the same request, and we broke it down. For the demo today, I will show you the two streams. The Claude 4.7 Opus in Anthropic Cloud, or the hybrid mode, where we divide the 5 tasks that there are the classifier, and this is a keyword, so start using now. The classifier decided was required in order to satisfy the prompt. In the hybrid mode, what we decided to do, or the classifier decided to do, is 5 tasks. One is a median. It requires up to 32 billion parameter model. And 3 are easy that can run in an 8 billion parameter model in the PC. And 1 is hard, the coming lanterns floating in the background, that is executed in a Claude 4.7 Opus. And we run it, and we let them race and see what is the result to that. Sound like an interesting thing to see? Yeah? Want to see the race? There is an F1 car parked in the front. An AMG. I love F1. Okay. These are running. In the left-hand side, you have the Opus 4.7. As you expect, it's running faster because the hybrid model hasn't been optimized. I expect that to change significantly over time as our software team, where is my software team, is sitting. The head of the software team is sitting in the back. I'm blaming on him. So we had to optimize it a little bit better. And you can see the counters going. I'm going to accelerate this a little bit because then you might get bored by seeing code running, watching the matrix fall down. Right? That's like watching the matrix writing Python code. I'm going to move it faster. So now you have the same result. Because that was done prepared for Computex, it says thank you Taiwan. But as you see in the left-hand side and the right-hand side is the same picture. The lanterns actually move when it's running. And the model that executed result the same. But the difference is, the one in the left is 4 times more expensive than the one on the right. The one on the left took 21 cents, token-wise. Now imagine that this is not just at the developer, because everything we do today is actually code. Any prompt, create a derivative. Either you tell it to create a PowerPoint presentation, review Excel spreadsheet, compile data sets. It is writing code. It's writing Python, it's JavaScript, HTML compilations. It's doing code. And as you write code, and if you classify that data correctly, you can, in this particular case, we're saving for X, and we said before, at least 50% you can reduce. So look at the 2 extremes of that gamut, the opportunity that presents itself. If people, how we can justify paying for X more? It's hard to justify, right? Like in the old days, I did learn to program in an IBM 460, and that all, with a punch card and everything. So if you ever know what that is, look it up in a museum. And we send everything to a server, right? And we had a little monitor, and in my case, a punch card machine, not even a terminal for my case, because I was in engineering, electrical engineering, not in computer science. So terminal was for computer science, not for engineers, not for electrical engineers. Anyway, I'm digressing like an old man. So for X, 20 cents versus 5.5 cents. $14,000 a month if you do this in a recurrent fashion. So imagine your marketing team is preparing web pages, product launches, and so on and so forth, and versus almost $4,000 differential. Well, this is one way to save the planet, guys. Don't send it to everything to the cloud. Send what matters to the cloud. All right, so what does this mean for provider, developer, and users? All benefits simultaneously. 65% at least cloud GPU cycles consumed. We can get, I didn't show demonstration of sub-milliseconds because the demo didn't provide that. If the demo would have shown my sub-millisecond latency, I would have shown you that. But research showed that we can get to sub-200 milliseconds responses on device turnaround, and at least user cost reduction. This is tremendous value. Tremendous, tremendous value. So if you're, in the case of that partner that is paying $35,000 a month per developer, per developer, if they integrate a solution like this, right? $15,000 savings, or more than $15,000 savings, that can buy a lot of hardware. Hardware that stays with the user 3-4 years between the replacement cycle. They can replace the cycle hardware every month, and it still will be saving money. I mean, get that in. Right? You can replace your hardware every month, and you're still saving money. It's an incredible, powerful equation. So let's talk about how to achieve that. The way we envision this at 3 tiers in this case, 13 billions and below for sure, up to 34 billions in soon-to-release architectures. Is you complexity score between, this is logic entropy. You will see the research in the back. In a score 1 to 6, smaller models, we run it locally, up to 100 billion parameters, or slightly more, 120 billion parameters, can run on-prem workstations or servers. These are not water cooled. This is just something like, look, a little box that's sitting under your desk. Or anything bigger than that, you just send it to the cloud, like security audits, code repo, right? Send it to the cloud. We look at the energy entropy threshold for that, or the entropy threshold for that. And the way we look at how to make a possible way to look at it, that's what we call the classifier. The classifier become a very important IP, and you developers should think about the classifier as your capability. I mean, the concept is simple. Like any great idea, the concept is simple. The opportunity is developing the IP that solves the problem better than others. The way we look at this problem is for prompt analysis, right? We first look at the prompt and look at the token count for the prompt. Think about a small classifier, which is a small model, that need to react in sub 20 milliseconds. Why sub 20 milliseconds? Because you start looking at below 200 millisecond threshold response time. You look at 10% of that, a rule of thumb, 20 milliseconds is my response time. That's my top threshold for my classifier. So I say my classifier cannot take more than 20 milliseconds, and it cannot use more than 50 tokens. So it's lost in the noise of the request. If you see me squinting, it's for two reasons. I know use two lights in my face. I'm a shy person, believe it or not. And second, I'm short-sighted, so I want to focus in your face, and then I have to squint. Second, we look at the abstract system tree parse depth, meaning when you're parsing, how deep is the tree of decision logic? Do you have an if clause in your prompt, right? Is you say, okay, create a web page that had a landing page for Snapdragon X2 Elite. However, if we haven't released the Snapdragon X2 Elite yet, I want you to create a page that looks like this. However, I want a different page that does this and use data from this set or that set. So your depth of the decision tree of what the model had to do is increasing. So you can create the classifier to look into how deeply embedded is your decision tree to make a decision of where the request needs to go. The third thing we looked at is cross-file reference count. So look at this email and look at that presentation. Search the web for this information. Combine that and to create a solution. The more cross-file reference count, by the way, all these are thresholds that you can manipulate to find your best point. And actually, your model can be adaptive for the, you can make it recursive to make your model be adaptive and self-learning. And finally, security flags. Is an authorization request, it's a crypto injection, it's an injection, a compliance term. Any match that trigger a security compliance query triggered a red flag for us when we look at the classifier. To break that down into, okay, let's look at this carefully before we go further. When we had a security red flag, then we paid very deep attention to a confident fallback. So what we do in the confident fallback is the entropy of the query is getting too complex, right? Real time as the query is being executed, then we can stop the query and fall back to cloud. So what you do is, okay, the entropy is increasing. The model say yes, but it's taking too long, right? So that means that our entropy is high. So before it goes deeper into the weeds, stop it and reshuffle up to the cloud. So it's always a fallback situation. And then you can look at what went wrong, right, over time and correct it. So the power here for us developers is how we build that classifier. Obviously, there's a lot of work that can be done in order to improve it. create more powerful classifiers. That's the nature of the power of the IP that can be created for companies. Like I have seen tons of companies here at the Build conference that would be super interested to create a powerful classifiers that allows to create these solutions. Almost on time to open for questions, but I don't know. You guys don't seem like you had too many questions. Clear as mud. This is a boring. The other ones were kind of boring. This is the most boring page. You know, when you do research, you like research reference. I'm not going to read my research reference. I talk here about entropy calculations, you know, quantization research. I'm sorry. And edge inference and routing capabilities, research that has happened in this. I'm not going to get attribution for all the good work that people had done. I mean, to me, but to all the people that had done research, as you know. New research is based on some other people's research and take it to the next level. So thank you to all those ladies and gentlemen that have worked on creating enough capacity for us to talk about these things at this point in time. So finally, wrapping it up for us. The evidence is 73% can be resolvable. If you put a gap on it, at 50%, it would be super happy. Even 10% is a lot of money. But research showed the max top of that is about 73% today. 58% of Stack Overflow developer service in 2024. People are using tools in 2024 for documentation boilerplates. Okay, that is 100% local. If you look at 73% enterprise code-based workload analytics study, 50 developers team analysis cross-maintain heavy code base, 50 to 60% use lower edge resolution. So that means also small models running locally. And even if you go to the opportunity to optimize for integer quantization, you will find out you lose about only 5% on your precision. We give you tremendous memory capacity even for a local device, tremendous reduction in power, tremendous reduction on bandwidth requirements. That makes your model super powerful to execute and a power efficient NPU. So build it yourself. That's my call to action. Look at your request logs. Categorize your last week AI coding request by complexity. Find that threshold for you. At the simple request, completion boilerplates, limb fixes. Route by complexity, not by habit. It's easy to send everything to a bigger model. You know it's going to solve it. But it's like moving a gas hustler car to go for groceries 2 blocks away. Right? Just, it's a waste of resources. Measure for 2 weeks, right? Track the token cost, the latency, and then repeat. Optimize your classifier and repeat. Rinse and repeat. That is the solution space. We can not only save money, but we can save some polar bears habitat and some penguins in the other side of the world, right, as we do this. And I will open it up for questions. I was asked to plan some questions, but I didn't do it. The gentleman in the front. If you can tell me who you are, that would be great.
This is Nathan. I'm with 𝗦𝗲𝗀𝗀𝗃𝗀. When we do these prompts, oftentimes my prompts are quite large, and the prompts themselves are complex, but they could be broken down and sent off to separate agents or have pieces done here, there, and elsewhere. My typical work, I rarely see that happen with the automated features in Cline and Claude, but periodically I do see that come up. Now this classifier you were talking about, that sounds like something we would have to write?
Great. Thank you for the question. The classifiers are not readily available. We are working on that research ourselves and make available that classifier. But I'm promoting the ecosystem to create them.
Okay.
Right? Now, you could create it yourself. I don't think that that is a powerful IP to have, and it's a competitive advantage to create a IP that create that classification opportunity. So you think about it, you're competing with, oh no, you're lucky, you know your next competitor. Is you both are using the same classifier, you both do not have value competitive advantage for your IT enterprise support. If you write the classifier yourself, you might create a competitive advantage for you. Or you can have people write the classifier for you. I don't think it's that difficult. For the first order classifier, right? It's not that difficult. Getting to a very known classifier that is retroactively learning and improving over time, that is a little more sophisticated work. And I encourage all of you to develop that classifier. The classifier will live in an orchestrator. So think about it that way. Your orchestrator should own the classifier because the orchestrator is the one that is going to ship the request to agents. And the agents are attached to models. So now there's a different problem there that also we are doing research on, which is why model, when, and who. Today, we do attach them by knowledge, right? We know this model is capable to do foo, therefore, we send it to foo model, right? In the near future, I expect that to change, meaning capabilities of the model, the orchestrators, the devices need to be known in a global fashion. Sorry, did I answer? I hope I answered your question. Great question. Could you tell me who you are? I appreciate it.
Yeah, I'm Bridget. I'm an engineer at Vasion, and I was kind of interested more on the classifier, and like on this slide, you had like a fifth section that you haven't talked about, so I was kind of, and then also talking about classifiers when you're like developing from yourself, how you can standardize them across like an organization, because I know it's more of like an independent thing currently.
The fifth leg, I thought I did mention it, but let me restate it because mine had not landed. The fifth leg is your fallback, right? The 4 prongs on your classifier will not be sufficient every time, right? They will not. Therefore, there will be, let's call it a prediction error. Your classifier is making a prediction. So like we did in CPU architecture, I did work on CPU architecture at some point in my career. When we look at CPU architecture, we have prefetcher, and prefetcher had to determine what is the next instruction to execute and go in the right direction. So if you know that, you also know that it's not perfect. And failing you had to have a fallback. When it failed, you had to have a fallback. So it's the same concept here. I'm using that architecture knowledge to say, okay, I had to have a fallback. Is my predictor is failing to classify this correctly? I need to have a measure of success while it's executing. And the measure of success is the entropy. When I look at the entropy as measured by, I put the research there, I measure by, and that entropy is growing faster than my expectation, then I abort the request. And then, in this case, you have 2 choices. You can try to reclassify it, right? You have more than 2, but at least 2. You can try to reclassify it, although the answer will be the same. You use the same parameter, you have learned nothing, and or send it to the cloud, right? So eat the bullet, send it to the cloud, and pay the cost, because you want a proper answer, not a hallucinated answer.
Thanks.
Yeah, thank you.
Hey, I'm Malika. I'm from Qualcomm product management team.
I swear I didn't plan you to ask a question.
You did not. Question I had was, if the models have this bigger size and smaller size subsets that we can query for different tasks, do you perceive any system level changes? Like how will the application development be around it?
I don't think it's different than application development that leans on orchestration, right? So
I mean, if time permits, can we go through like creating a video, right? If we make this video creation model into 3 parts, one of audio, video, and sentiment analysis. Now the application, instead of managing one model output, it now has 3 model outputs.
Yes, that's one way, and the other one is within that specific track. So you have 3 tracks, right? The video, the sentiment, and the audio in your example. Even within those 3 tracks, you can classify based on the task assigned to the query. So you can even parse that even further. Each one of them will have their own type of entropy limits, and each one of them will have a classifier format that diverse. You're talking Gen AI, right, in this case, which is behavior slightly different than LLMs, right, and in the case for measuring entropy and classification, but applied similar.
I see. Who will aggregate the inputs from all
the
of
orchestrator.
Orchestrator will already
The classifier.
I
The
see.
classifier had an input, an execution monitoring, and aggregation output that belonging to the orchestrator routing logic.
Awesome. Thank you.
At least that's the way we're thinking about it. As I said, this is a work in progress.
Thank you.
I haven't written published the paper yet for the research, but I promise I will do so. You're getting a preview of the paper. All right, I have 2 minutes, 45 seconds to spare. That is one question, or I can send you to drink some coffee. All right, thank you very much. I really appreciate your time, and welcome to Bill.